Okay, so in the first part of the video, na-discuss natin yung constitutional isomer and yung stereoisomer, no? So, ano yung difference ng dalawa? So, when you say constitutional isomers, the connectivities are different. Magkaiba sila ng format, magkaiba sila ng constitution. However, if we have stereoisomers, no, our groups, no, the functional groups or the substituents are connected to the same atom, to the same carbon atom. The only difference is magkaiba sila ng orientation in space, no. Pwedeng orientation yung nakapataas, pwedeng naka-down, naka-equatorial, axial, no. Pwedeng nasa harap, pwedeng nasa likod, no. So, yun yung difference between the two. So, constitutional isomers, magkakaiba yung dinudugtungan na atom. For stereoisomers, iisa yung dinudugtungan na atom. Ang difference lang ay yung kanyang position. Kung nasa harap, nasa likod, nasa taas, or nasa baba. No? And last time, we are able to encounter enantiomers. No? So, enantiomers is one of the type, no? Isa silang type ng stereoisomer wherein they are mirror images but they are not superimposable. No? So, for example, yung kamay. So, these are enantiomers. No? So, you can see these two are mirror image, no, ng isa't isa. So, ito naka-mirror to dito. Pero, pag pinagpatong ko yan, they are not superimposable. Okay, so that means these are different molecules. No? Okay. So, ngayon, let's proceed with the next topic na itutuloy natin ngayon, no? Which is the designation of R and S configuration for your enantiomers. Now. Okay, so for example, we have these two compounds. Alam natin enantiomers to, yes. Pero, alam din natin that enantiomers have different properties. They have different chemical properties, no? They have different behaviors. So, hindi pwedeng ito at ito, iisa sila ng pangalan, no? Hindi pwedeng ito si Gemerlin, ito si Gemerlin din. Hindi pwede yun. Kasi magkaiba sila ng functionality, magkaiba sila ng orientation in space. Hence, they are different molecules, no? Okay. So, to remove the ambiguity, no, para ma-distinguish natin yung dalawa, we use the Cahn-Ingold-Prelog system, no, wherein we designate one molecule as S, the other as R. No? So, para may difference yung dalawa. No? Okay, so yun. Enantiomers, no, meron tayong R and S configurations. No? So, ito yung rules. No? So, this is the stepwise rules and designating the RNS configuration based on the Cahn-Ingold-Prelog system. So number one is that you check the stereocenter and you identify the atomic numbers, no, of the atoms connected to it. No. So you prioritize it using numbers 1 to 4, wherein the 4 is the least priority, 1 is the topmost priority. Okay? Yung 4 yung least, yung 1 yung topmost priority. Okay? So yan. Then after identifying the functional groups, I mean the priorities of your groups, no? You arrange the molecule wherein the least priority is facing away from you. So, if ever nakaharap yan sa'yo, baliktarin mo yung molecule para nakatalikod na siya. Okay? Pero kung nakaharap na sa'yo yung pag yung least priority nakalayo na sa'yo, okay na yun. Then, you check the numbers 1, 2, 3 and see kung ano yung rotation niya, whether that's clockwise or counterclockwise. No? So, if that's clockwise, then you have an R configuration. If that's counterclockwise, then you have S configuration. Okay? So, later on, papakita ko yung hand method. No? The only difference lang dito sa gagawin natin is that yung aking camera, hindi siya naka-flip. No? So, kung naka-right turn ako dito sa inyong point of view, naka-left turn. So, I'm not sure. So, pero bear with me. Sundan nyo na lang yung sasabihin ko pag nag-rotate ako sa kamay. Okay? So anyway, so let's proceed. No? So for example, we have this molecule. Draw ko muna. Yung wala pang labels. Okay, so syempre, ang instinct natin is that yung stereocenter niyan ay ito. Matik yan yung instinct natin. Kasi in this carbon atom, you have 4 different groups attached to it. No? You have this group, the CH2CH3 group. You have this OCH2CH3 group, yung Cl, and yung H group. No? Okay, so this is a stereocenter. No? Yung iba hindi. No? This is the chirality center. No? Okay. So, anong gagawin natin dito? So, sabi natin, we will prioritize the substituents, no, according to the atomic number. No? So, yan. So, the highest priority will be given to the atom with the highest atomic number. No? So, that makes chlorine our first priority. Hence, may 1 doon. Then, next is oxygen. Since this is the 8th element, etong chlorine ay 17th element na. Kasi ito 8. Kasi yung carbon dito, this is the 6th element. So, it will have the 3rd priority. And yung hydrogen, no, as usual, pag hydrogen yan, usually last priority yan. Okay? So, ayan. No? Then, so, we just prioritized. No? I mean, we labeled the priorities of our groups, no, in the connected to the stereocenters. Stereocenter rather. Okay? So, yun yung first step, no? Lagyan mo sila ng label. The second step is for you to arrange the molecule in such way the least priority faces away from you. So, kailangan yung least priority nasa likod, nakalayo sa'yo. Kasi tignan nyo yung molecule natin. Ito yung least priority, yung hydrogen. Pero, mapapansin nyo, this is wedge. Nakatutok yan sa'yo. Nakapag ganun yan sa'yo, pointing towards you yan. So, kailangan baliktarin yan. So, para mabaliktad yan, we have to flip the molecule by 180 degrees. I-flip mo yung molecule. So, as you flip the molecule, what will happen is this. No? So, itong OCH2CH3 na yan, mapupunta yan dito sa left side. No? And then, itong CH2CH3, mapupunta siya sa right side. No? Then, yung Cl, mapupunta na sa harap. Yung H, mapupunta na sa likod. No? So, this will be the result after flipping your molecule 180 degrees. No? And so, flip mo siya so that the least priority will be facing away from you. No? Okay? So, ganun. One way, no, para mas mapadali ito is to do this, no. O instead of drawing the molecule, i-draw mo na lang yung arrangement ng priorities, no. So for example, paano yung ginagawa na? So kunwari ito, i-draw ko to in this manner. Paano yan? Gawa ka lang ng ganitong format, no. Ganyan talaga format niyan. Then lagay mo yung numbers, no. So ito 4, ito 1, ito 2, ito 3. Tapos ano sabi natin? Yung 4, kailangan nasa likod, no? So, you have to flip it. So, flip natin yan. So, as a result, you will have this, no? Yung 1, mapupunta sa harap. Yung 4, nasa likod. Pero, ang consequence niyan, itong 3 and 2, magpapalit din ng pwesto. Okay? So, ganun yung shortcut, no? So, instead of drawing the molecule, i-draw mo na lang itong format na to. No? So, gawa ka ng ganito. Isang dash, isang wedge. No? So, lagay mo yung priority number. 1, 2, 3, 4. Then, yung 4, yun yung ilalagay mo sa dash. Yan yung last priority. Always. Okay? Okay, so pagka-flip mo ng molecule, then, proceed tayo sa third rule. So, according to the third rule is that you will check the priorities 1, 2, 3, then see kung paano yung rotation nila. Whether they are moving clockwise or counterclockwise. No? So, yan. So, this is 1, 2, 3. Yung 4, hindi mo titignan yan. No? So, tignan mo yung rotation niya. Paano? Pagdugtungin mo lang yan. So, this is 1, 2, 3. Anong rotation yan? Clockwise yan. So, when your rotation is counterclockwise pala. When your rotation is counterclockwise, you have S configuration. If that is clockwise, on the other hand, that's R in configuration. Okay? So, ganun lang yung process dito. So, paano yan, sir, sa kamay? So, yung kamay method niyan, so, end ko yung muna yung sharing ng screen. Okay, so ganito yung kamay method, no? So, ganyan ka. Ayan, so gagawin mo to. So, this is 1, 2, 3, ito yung 4. Okay. So, ito yung least priority nyo, yung arm nyo. Tapos, itong ano nyo, itong thumb finger, yung hintuturo, and then yung middle finger nyo, you will assign the priorities 1, 2, 3 here. No? So, this is 4. Tapos, ano yung sabi dyan? No? Dapat, yung priority number 4, that's facing away from you. Kung gagawin mo yan, ito yung kamay mo, it should be pointing outwards. No? So, meaning, yung numbers 1, 2, 3, this is pointing sa mukha mo. Itong 4, nasa likod. No? Okay. Then, mag-a-assign ka ng number. So, itong nasa taas, ito yung 1. Itong nasa left, ito yung 2. Itong nasa right, ito yung 3. Okay. So, ito yung 1, ito yung 2, ito yung 3. So, gawin nyo na lang sa kamay nyo para mas makita nyo. So, para nakapag-ganon siya sa inyo. This is 1, this is 2, this is 3. So, ito yung point of view ko. Then, paano ko malalaman yung rotation? So, this is 1, 2, 3. Paikutin ko siya in 1, 2, 3 direction. Pag nakikita nyo yung kamay nyo, nagka-counterclockwise. Pag nagka-counterclockwise yung hands nyo, that's S configuration. Pero kapag clockwise yan, for example, 1, 2, 3, pag clockwise yan, nakikita nyo, clockwise yung ikot ng kamay nyo, that's R configuration. Counterclockwise S, clockwise R. Okay? Fourth priority, 1, 2, 3. Check mo yung rotation. Counterclockwise S, clockwise R. So, ganun yung method niya sa kamay-kamay, no? So, yun yung handheld, yun yung hand method, no? So, yan. So, you will use that later, no? Mas convenient yun, no? Kapag ginamit nyo mamaya. So, anyway, sasabayan ko naman kayo paggagamit kayo, no? Para hindi magtaka yung ibang tao sa mga ginagawa nyo sa kamay nyo. Kasi usually sa chemistry, nagaganon-ganon talaga kami. No? Para malaman namin yung orientation, kung R ba yan or S na. Okay, so anyway, so let's proceed. Okay, so kunwari, sir, this is a chirality center. Pero ang groups, ang atoms na nakakabit sa kanya is carbon and carbon here. So may tie doon. No? So in case of tie, kailangan i-check mo yung katabi niya pang atom. So, tignan mo yung mga katabi niya pang atom. Okay, so kunwari dito tayo to, si H2 to, ayun, si H2 yon. So, anong ginagawa natin last time? Check mo yung katabi pa, no? Yung katabi niya is ito na. Ito. So, ito yung original na tinignan natin. Ito na yung kasunod. Pati ayun. So, check mo yung mga atoms dyan. You have carbon, attached to carbon, carbon, and hydrogen. Kaya CCH. So, ano yung mga nakadugtong dito sa carbon na to? Hydrogen. Tapos, dalawang carbon. Sa CH3, CH3 doon. Dito naman, ano yung nakakonect dyan? Itong carbon na to, and then yung dalawang hydrogens. No? Okay, so mapapansin nyo, this will be the most priority than this one. Bakit? No? Kasi, etong mga nakadugtong sa kanya, may dalawang carbon na nakadugtong sa kanya. No? This carbon here, and that's this carbon there. Dito, isang carbon lang nakadugtong sa kanya. Ano yun? Etong kasunod. No? So, this will have the greater priority over this one. Okay? So, ganun yung case dyan. Okay? So, ganun lang. So, again, nangyayari yun kapag may tie. No? Kunwari, ito, may tie uli. No? Carbon to. Carbon to. Check mo yung kadugtong. Ito, oxygen. Yun, carbon. Okay. So, sino mas magiging priority mo? Siyempre, may naka-oxygen na nakadugtong. So, this will have the second priority. This will have the third priority. So, ganun yung mangyayari. So, kunwari naman, you have double bonds. No? So, when you have double bonds, i-consider mo siya as single bonds to the same atom. Kunwari, ito, carbon na to. Kunwari, i-compare mo yan sa ibang carbon. No? So, itong carbon na to, this is double bonded to oxygen. So, ang bilang ng oxygen atom dyan ay 2. So, kung may triple bond dyan, 3 yung bilang ng atom na yan. Pag 2 bond yan, 2 yung bilang na atom na yan. Na yung nakadugtong dito sa carbon na yan. Okay, so ano yung mga nakadugtong dito sa carbon na to? Oxygen, another oxygen, then hydrogen. So, ganun yung ginagawa kapag may double bonds na. Okay? So, ganun lang. So, ito yung handheld, models. No? Pwede yung kamay-kamay nyo na lang or ito na lang yung ginawa natin kanina. No? Okay? So, yan. So, here are some tricks that we can use. Switching the two groups on a chirality center will produce its opposite configuration. No? So, hindi i-flip yung entire molecule. No? Pagpalitin mo lang yung 1 and 4, ginawa mo 4 and 1. So, magkaibang na yan, configuration. No? So, yan. Ano ba? Yun lang. So yun lang. Yun na yung simple ideas. So again, so let's summarize the Cahn-Ingold-Prelog rules. Identify the 4 atoms connected to your chirality center. Then you assign the priorities, 1 for the highest, 4 for the lowest. Usually, the hydrogen atom will have the priority 4. Okay? Then 3, ano gagawin mo? Yung 4th priority ilalagay sa likod. Then you rotate the molecule in step 4. If that's clockwise, that's R. If that is counterclockwise, that is S in configuration. So for example, let's try this molecule here. So hindi pinapakita yung hydrogen ay nasa harap, no? So lagay ko dyan yung hydrogen. So this is my only chirality center. Yan lang naman. So let's assign priorities, no? Sige. Ano yung mga nakadugtong sa kanya? Hydrogen, nitrogen, carbon, carbon na may oxygen. Okay, so judge natin. Sino yung heaviest atom? Sino yung mas mataas yung atomic number? Siyempre, nitrogen. So this group will bear the priority 1. Ano susunod? Yung carbon. No? Kaso ganito, tignan nyo. Ito carbon to. Ito carbon din to. So tie. So kapag tie, sundin mo yung kasunod. No? Check mo yung kasunod. Carbon to. Ano yung kasunod yan? Oxygen. No? Dito, ano kasunod niya? Carbon pa rin. So mas lamang itong nasa left kaysa yung nasa right na. Bakit? Because of the katabi niya. Oxygen yun eh. So mas okay to kaysa dito sa carbon. So this will have the second highest priority. This will be the 3rd priority. And as usual, yung hydrogen ay 4th priority. So ano pwede natin gawin dyan? So wag na natin i-drawing yung entire molecule. No? Nakakapagod eh. So gawin natin yung handheld format. Yung nakapaganon. Yung nakapaganon. Okay. Parang kang gangster, no? Ganun ka sa kanto. Magtataka yung mga tao. So, gagawa ko ng skeleton nito, no? Na yung priorities lang ipapakita ko. So, ito yung 2, ito yung 3. Mapansin niyo yung 1 nasa likod. Tapos yung 4 nasa harap. I-rotate ko lang siya by this direction para maging yung typical illustration natin. Rotate ko lang, ha? Yan. Para maging ganyan. Kasi nasa taas to eh. Itong dalawa eh. Kung nasa baba yan, okay. Ito na yung makukuha natin. Pero nasa taas kasi. So, i-flip ko lang by 180 degrees. No? So, ganun pa rin naman. So, yung 1 nasa likod, yung 4 nasa harap. Pero ano mangyayari? Yung 3, pag flip mo yan, mapupunta yan dito sa left. Yung 2, pag flip mo yan, mapupunta yan dito sa right. No? Okay. So, this is our handheld illustration. Tapos, anong gagawin natin dito sa handheld illustration? We make sure that the least priority is facing away us. So, kailangan naka-face away siya. So, anong gagawin natin dyan? Rotate. Ay, ba't ganyan yung rotate ko? Teka lang, ayusin ko. Okay. So, i-rotate ko yan, no? Rotate ko siya pa ganun. So, medyo maayos. Madami kang ayusin, no? Kaya sabi ko sa inyo, 3D dapat mag-isip ngayon. Okay. So, paikutin ko yan, no? Paikutin ko yan ng pagganon. Aray, tumama yung pencil. I-rotate ko yan ng pagganon, no? I-flip ko lang siya vertically, no? So, what will happen if I flip this vertically, yung 4 na nasa harap, mapupunta na siya ngayon sa likod. Yung 1 sa likod, mapupunta sa harap, no? Ano pa? Yung 2 and 3, magsi-switch places din sila. Okay? So, ganun yung idea. Then, we can use the hand method or i-arrow-arrow na lang natin. So, i-arrow ko na lang para mas makita nyo. Maliit lang i-insert ko ng picture. So, this is 1, 2, 3. Tignan natin yung rotation yan. 1, 2, 3. So, ano yan? Is it clockwise or counterclockwise? That is counterclockwise. So, counterclockwise yan. So, that means this is the S enantiomer. No? So, this is S enantiomer. Okay, so, ganun lang yung rotation. No? Okay, so, I will have some more examples here. Dami. Sagutan ko na lang yung A and B. Let's practice na lang kayo sa iba. Okay, so anyway, yung test bank, yung ano naman, yung solutions manual ng book nasa Canvas naman. So you can download them, no? So na-identify ko na yung stereo centers. Okay, so I have 2 stereo centers, no? Okay, so sige. So, kailangan magkaibang kulay na lang. So this is red. This will be purple. Ay, bakit yun? Teka lang. Yun. Okay, so yan. So again, di natin ito-drawing yung molecule, nakakatamad eh. Gawin lang natin yung handheld method. Okay, so dito ako sa ephedrine. A bronchodilator and decongestant obtained from Chinese plant, Ephedra sinica. So, pampatanggal siya ng sikip ng dibdib. Okay, so yung red, focus ako sa red, no? So that is one of my chirality center. So what are the atoms attached to the red? No? Siyempre, yung hydrogens di pinapakita dyan, pero nasa likod yan. Okay? So yung OH nasa harap, yung H nasa likod. Then ito yung isa, phenyl group. You have your benzene here, then the rest of the structure on the right side. Okay, so gawin natin yung format dyan. Priorities pala muna. So let's prioritize the groups. Sino yung first priority? Yung biggest atomic number, which is oxygen. So ito yung magiging highest priority. Okay. So this is priority 1. Second priority. This is carbon. This is carbon. Same priority. So, anong gagawin mo pag ganun? Check the neighboring atom. So, ano yung neighboring atom dito? Carbon na naman. Dito, ano yung katabi niya? May carbon, may nitrogen din. So, ito yung better, no? Na second priority. So, this will be my second priority. This will be my third. And, of course, we know hydrogen. Last priority yun. Okay? So, ganun lang. Okay, so gawin ko yung handheld format dyan. No? Okay, so yan. So ano yung priority? 1 yung nasa harap, 4 nasa likod, 3 andito, yung 2 andun. Okay? Sige, so then after assigning the priorities, we check the rotation of 1, 2, and 3. So, nasa likod na yung 4, so wala na tayong gagawin. You check the rotation na lang. So, pagdugtungin natin yung 1, 2, and 3. 1, 2, and 3. Anong rotation yon? Clockwise. So, clockwise yan. So, ibig sabihin yan, this center is R in configuration. Okay? So, R yan. Ganun lang. Aburahin ko muna. Okay? So, ganun yung pag-identify ng configuration na. So, this, ay, hala. Bakit ganun? So, ganun lang yung gagawin nyo, no? So this center is R in configuration. Okay na tayo dyan, no? So, yan. So, ito yung rotation niya. Kung gusto niyo makita, no? Yan. So, punta naman tayo dito sa next chirality center. Itong purple kanina. Okay, so in this next chirality center, let's assign the priorities. By the way, the hydrogen is C din, no? So, nasa likod yung hydrogen. Okay, so let's assign priorities. This is carbon. Ang nakadugtong sa kanya ay nitrogen, carbon, and carbon. Sino yung ipaprioritize? Siyempre yung nitrogen. So, this will have our priority 1. Tapos, ano? The second priority, ito ba or ito? Ito dapat. No? This will be my second priority. Bakit? Kasi itong carbon na to, saan to naka-attach? Sa hydrogens. Itong carbon na to, saan to nakadugtong? May oxygen dun, oh. So, panalo to. Okay. This is the first priority. This is the second priority. This is my third priority. Itong methyl group dyan. And lastly, yung hydrogen sa likod, no? So, gawin natin yung hand model illustration dito. So, kapag ganun siya, so, ito yung 4, ito yung 3, ito yung 2, ito yung 1. So, ano gagawin kapag nakabaliktad? I-flip mo sila. No? Flip mo yung molecule, yung model mo. So, flip ko lang, ha. So, nasa harap pa rin yung 3, nasa likod yung 4. Yung 1, dito siya. Pag flinip mo yan, mapupunta yan doon, no? Yung 2, andun siya. Pag flinip mo yan, pag ganun, andun siya mapupunta. Okay? So, yan. 3, 1, 2. Then, ano gagawin? I-check kung yung 4 nasa likod. Nasa likod ba yung 4? Yes. Nasa likod yung 4. Okay, so check natin kung ano siya, R or S, no? Paano yan? Pag dugtong-dugtungin mo, yung 1, 2, 3. 1, 2, 3. Anong rotation yan? That's counterclockwise na. Counterclockwise yan. So, kapag counterclockwise, S yan. Okay? So, counterclockwise rotation niya. Pag ganun siya eh. Ito clockwise. So, R yan. Ito, S. So, counterclockwise yan. Okay? So, ganun lang. Okay? Hindi ko naburahin. Tapos na naman yan eh. So, yan. So, that is R. And this one is S in configuration. Okay? So, let's try letter B. So, si letter B naman. Letter B. Gawin ko yung red, ha? So, sige. Siyempre, ako naman gagawa nito lahat. Ako lang mag-isa dito eh. Okay, so, wala tayong H. Okay. So, ano yung mga nakadugtong dito? This is carbon. This is my double bond. So, carbon, carbon yun. This is carbon, then dalawang H. This is carbon connected to bromine. This is chlorine. So, the first priority will be Cl. No? So, ito yung first priority natin. That's priority 1. Tapos, Ano yung second priority natin? So, puro carbon na yan eh. Carbon to, carbon yun, no? So, itong carbon na to, may carbon na nakadugtong sa kanya na double bond. No? So, carbon, carbon, yung nakadugtong sa carbon na yan. Okay, again, pag may double bonds, we treat it as two separate carbon atoms. No? So, ito, yung carbon dito, may nakadugtong na hydrogen, hydrogen. No? So, ito yung magiging least priority natin. Okay. So, ito, between the two na lang, ito at ito. So, differentiate natin yung priority. This is carbon connected to a carbon. Ito naman, carbon connected to a bromine. So, this is better than this one. No? Kasi ito, carbon connected with carbon and hydrogen. No? So, this will be my second priority. This is my third, and that is my fourth. No? So, gawin natin yung handheld method dyan. Sir, paano yan? Kunwari, ganyan, no? Di ba usually yung 1 and 4 na, yung 4 natin nandito sa taas na. So, if that's the case, kunwari, ganyan yung naging itsura, you have to rotate the molecule, no? In such way na yung 4 mapupunta sa likod, no? So, i-rotate natin siya pag ganon, onte, no? So, yung 4 mapupunta sa likod, no? So, paano yung gagawin? So, imagine nyo na ng kamay nyo yan, no? Kamay nyo yan kunwari. So, ito, and ito, they are this part of the molecule. Teka lang. Ang hirap pala mag-visualize, no? Ang hirap pag online class. Hindi ko mapavisualize sa inyo. So anyway, ang kailangan lang natin gawin is itong 4 ilagay sa likod, no? So paano natin gagawin yan? So, ganito yan, no? So ito yung kamay nyo. Ito yung priority 4. Ito yung priority 3. Ito nasa likod. This is priority 2. Ito yung priority 1. Okay? So, ang gagawin mo lang is, i-flip mo yan, itong kamay na to. This is priority. Teka lang. Zoom natin. Okay, so ganito lang yung mangyayari, no? So, kunwari, ito yung kamay. Ang hirap mag-visualize, no? Anyway, so kunwari, ito yung bond, no? So, this is priority 4. This is priority 3. Itong 2 nasa likod, di ba? So, yun, pointing yun sa pader sa likod ko. Itong 1 nasa taas, no? This is 4, 2, 4, 3, 2, and 1. So, nakapaganon siya. So, this is 4, this is 3, this is 2, this is 1. So, kailangan itong 4 mapunta sa likod. So, ano lang gagawin mo? Itapat mo lang sa iyo. Okay? So, ganun. Ito yung 4. Pag gusto mo ito nasa likod, baliktarin mo lang yan. Nasa likod na yung 4. Kaso ang problema doon, paano na yung 1, 2, and 3? Paano yung magiging position nila? Okay. So, keep in mind, this is 3. Pwede lagyan nyo ng marker yung kamay nyo. This is 3. Sulat ko. Yung thumb ko ay 3. Priority 3 yan. Thumb is 3. Yung pointing finger, yung pang-point ko, that's my priority 1. And then my middle finger, that's priority 2. Okay? Then my arm is priority 4. 4, 2, and 4, 3, 1, and 2. So, malabo kasi mata ko. Hindi ko mabasa yung screen. So, this is 4, this is 3, this is 1, this is 2. So, para yung 4, mapunta sa likod, for you to visualize it, ikot mo lang yung kamay mo. Okay. So, tignan mo. Yung nasa taas ko, this is 1. Yung thumb ko, ito yung 3. Itong nasa likod kanina, nandito na siya sa left side ko. Ito na yung 2 na. Okay, so ganun. So ngayon, idodrawing ko na yun dito kung ano yung naging resulting image nung binaliktad ko yung kamay ko, nung gumanon ako. So, draw ko lang dito. Okay, so ito yung lalikod ko na. Ito yung kamay ko. Ito yung arm. Yun na yung 4. Okay. So, itong thumb ko, this is 3. This middle finger, this is 2. The pointing finger is 1. No? So, pag binaliktad ko, yung pointy finger nasa taas. So, ayan. So, andito siya. So, this is the pointy finger. This is my middle finger, no? On the left side ng point of view ko. Left side ko to eh. So, yun. So, nasa left side ko siya. This is 2. Yung 3 ko is nasa right side ng point of view ko. Okay, so ganun yung pag-visualize. Hindi nyo pala nakikita yung screen. So, pakita ko na yung screen. Okay, so ganyan na. So, nung flinip ko yung kamay ko, so itong 4, nasa likod ko na siya. Yan nangyari. Ito yung aking pointy finger, naka-point pataas. Itong aking middle finger, nasa left side ko yon nung gumanon ako. Nung nakaganyan. Ito, nasa left side ko to, no? Sa itsura ko. Ito, left side itong, ano na to, 2. Yung thumb ko, nasa right side, no? Yung 3. So, kaya ganito itsura na nangyari. Okay? So, now, na-drawing na natin yung hand drawing niya. Ang kailangan na lang natin gawin is i-rotate yung molecule. No? So, this 1, 2, 3. Is that R or S? So, that's counterclockwise. So, that's S. No? So, that means this chirality center is S in configuration. Ganun lang. No? Medyo mahirap gawin siya. No? Lalo na ngayong online class. Hindi nyo makikita yung ikot-ikot ng kamay ko. No? Pero ayan. So, sundan nyo na lang yung pag-ikot ng kamay. Ulit-ulitin nyo na lang yung video pag hindi na sundan, no? So, kasi ganun lang naman talaga yung shortcut dyan. Okay, so again, that chirality center is S, no? So, this one, S yan. Okay, so how about this purple one? Hindi pinapakita yung hydrogen, so nasa harap yan. Okay, so ganun. Let's assign the priorities. Of course, hydrogen, last one. Bromine, this will be my first priority. Kasi ang atomic number ng bromine ay 35. Okay, so siya yung number 1. Now, we are going to choose between this or this carbon. Sino yan? Sa left or sa right? Sino yung mas priority natin? Is it the left or the right? The answer should be yung nasa right. Bakit? Yung right, nakadugtong siya sa Cl. Itong nasa left, nakadugtong siya sa carbon uli. So, hindi maganda yon. Kailangan mas mataas yung atomic number na dinudugtungan niya. No? Okay, so Cl yun eh. So, this will be my second priority. This will be my third priority. Okay, so now, i-draw natin yung, yung hand view. No? So, ito. Kapaharap. This nasa likod. This is 1. This is 4. This is 3. And this is 2. Okay? So, kagaya naman ginagawa natin kanina, pag ganyan yung itsura, i-flip mo lang. No? Flip mo sila by 180. Okay? So, ganun lang. So, i-flip mo lang yan. Ipatayo mo. Then, ang gagawin mo, kailangan yung 4 nasa likod. No? Pero this time kasi nasa harap. So, we will flip the molecule again. Flip mo siya pag ganun. By 180 degrees again. So, you will have this. No? So, this is 4. This is 1. This will now be 3. This will now be 2 now. Okay, so ito yung ating final illustration. So let's check kung R or S yan. Okay, so pag dugtong-dugtongin ang 1, 2, and 3. There's 1, 2, and 3. So anong rotation niya? That's clockwise. Na? So clockwise yan. So pag clockwise, R. So that means the configuration of this carbon here is R. Okay? So yan. So yun lang yung idea. No? So if you want to take a screenshot, habang nanonood nyo lang kayo ng video, no, screenshot nyo siya para may copy kayo ng drawing. And yun nga, medyo ano siya ha, medyo 3D intensive. So yun. So sana may imagine nyo siya in 3D. No? Sana. Okay. So anyway, so yun lang. So that's how you designate R and S now. Okay, so now we can now differentiate this molecule and this molecule. So this is R-butanol, this is S2-butanol. No? In case na you have multiple stereocenters, no, you have to indicate the configuration of that stereocenter. No? For example, sa second carbon, that's R. Sa third carbon, that's S. So you have to indicate it 2R, 3S, and then the name of your molecule. No? Okay. So, pero kapag isa lang yung stereocenter mo, lagay mo lang R or S. No? Pero if you have multiple stereocenters, you have to indicate the stereoisomerism, no? Yung RNS configuration ng kada stereocenters. No? Okay, so ganun lang. On the second, that's R daw. On the third carbon, that's S. Then you proceed with the name of your substance. No? So yun lang. Okay, so itong optical activity, daanan lang natin to kasi hindi naman masyado tong bibigyan ng priority dito. No? Wala naman tayong lab eh. So hindi natin magagawa sa lab. No? So anyway, so this is optical activity. So ano yung meron dyan? No? So optical activity is how your molecule behaves with light. No? So ano ba yung alam natin sa light? No? Light is ganito itsura niya. So it has a magnetic field and electric field, no? So yan. So the molecule can actually rotate this this light, no? Itong movement ng light, no? Pwede niya i-twist yung light, no? Because of its stereochemistry, no? So yan. So pwede siya mag-interact with light. That means may optical activity yung ating molecules, na. Okay, so ano mangyayari na? So for example, you have your polarized light, meaning iisang direction lang yung light, na. Ano pwede mangyari dyan? Ito yung example dyan. So kunwari, this is your light source, then this is the polarized light. If it passes through a solution of a certain stereochemical if of a certain compound na may stereochemistry or stereoisomer, no? So pwede niya i-flip yung light, no? Okay, so papansin natin the light is vertical pagpunta sa labas, sa observer side naging horizontal siya. That is possible kasi yung ating molecule, di ba, may handedness nga siya. May left and right turn siya. So, yung left and right turn na yon, pwede umikot doon yung light particles. Pwede siya mag-reflect doon. Mag-refract. Ang better term is refraction pala. So, pwede mag-refract yung ilaw na sa ating solution ng compound with stereoisomerism. Okay, so this is used in sa ba ito ginagamit? Sa sugars, no? So yan, sa mga asukal na binibenta sa market, no? When they analyze them, they use this polarimeter, no? So makikita nila yung optical activity ng sugars, no? Yan. So makikita nila yung angle of bending ng light, no? Then may calculation silang gagamit to check the purity of that sugar, no? Okay, so yun lang. So ito hindi na natin dadaanan, ha. So ano lang yung pwede nyo makuhang lesson idea dito is that yung ating molecules that are um, R or S, they can bend the light, no? They can bend the polarized light, no? So, depending on some degree, no? Okay, so ang tawag natin sa bending ng light is the specific rotation, no? So, anyway, hindi natin i-focus na yan, no? For example, ito lang, no? So, for the R isomer, that's negative 23.1 degree. So, yung light, no? Magbe-bend siya ng pag ganon. So, for the S isomer naman, it will bend on the opposite direction, no? So, depending on the bending of the light, depending on the angle, if that's positive or negative, malalaman mo kung anong isomer meron ka, no? So, yun yung one way nila to measure the isomers count, no? Okay? Okay. So, if the rotation is positive, that is dextro-rotary, no? And pag negative yan, that's levorotary, no? So, yun lang yung mga kailangan yung malaman. And saan ito ginagamit? Sa amino acids, no? So, meron tayong D amino acids and L amino acids, no? So, that means yung D amino acids natin, they rotate the light in the positive angle. Yung ating L amino acid, which exists on biological systems, they rotate the light on the negative direction. Okay? So, yun lang. So, I don't know if may biochem kayo, no? Pero dun na lang siguro. So, yun lang yung kailangan ko ma-share sa inyo. Okay? Okay, so now let's proceed to the next one. No? So, last time we are able, kanina lang pala, we are able to check yung ating enantiomers. What do we know about enantiomers? They are stereoisomers that are mirror images but not superimposable. Hindi mo sila pwede mapagpatong. Another version of stereoisomer is the diastereomers. No? So, ano meron sa diastereomers? No? They are non-superimposable images and not mirror images. No? So, hindi talaga sila identical. No? Hindi sila mirror images and at the same time, hindi mo rin sila pwede pagpatungin. Okay? So, yun. So, ano uli? Yung difference? Pag enantiomer, mirror image. So, pag nilagyan mo yan ng plane, pag nilagyan mo yan ng ng salamin, so yan, mirror image tong kamay ko, no? So, this is enantiomer. Pero pag diastereomer yan, they are not mirror images and they are not also superimposable. So, ibig sabihin, hindi talaga sila identical, no? So, since hindi sila identical, they have different physical properties, no? So, magkaiba sila ng property. So, let's take, for example, this is 2-butene. So, if you're going to take the mirror image niyan, is this a mirror image? Ito ba ay mirror nito? No. So, hindi sila mirror images, no? And pag pinagpatong mo yan, hindi rin sila superimposable, no? So, that means that these two are diastereomers. No? So, pag pinagpatong mo yung molecule na yan, itong CH3, papatong yan dito. Itong CH3, papatong siya dito, hindi doon. So, that means they are non-superimposable, no? And not mirror image as well. So, if we have that combination, that means we have diastereomers, no? Okay, so let's consider this, no? So, itong molecule na to, this is a mirror image na. Ito at ito, mirror image yan na. So, yan. So, yan. Binaliktad lang na. So, mirror image yan. Ito rin. Ito at ito ay mirror image din na. So, this and this, mirror image yan. Ito and ito, these are also mirror images. Flinip lang. Para pag pinagpatong, makikita nyo na non-superimposable sila. And this one as well. So, these are also mirror image, no? And not superimposable. Okay? However, kunwari, I'm going to compare this and this. Are they mirror images? Obviously not. No? Hindi sila mirror images. And they are not also superimposable. So, these two are diastereomers. Ano pa yung mga diastereomers natin dito? Ito at ito. They are also not diastereomers. no? That means kung hindi siya mirror images, then hindi yun hindi siya enantiomer, no? So diastereomer yung tawag doon, no? So these are your pair of your mirror images. These are your enantiomers. Pero yung kabilang molecule niya, kunwari ito at ito, diastereomer yan. Ito at ito, diastereomer yan. Ito at ito, diastereomer. This and that, diastereomer. This and that, diastereomer. Ito at yun, diastereomer. So mapapansin nyo, ang daming diastereomer, no? Yes. Kasi yung kanyang mirror image ay isa lang, no? So silang dalawa lang talaga, pair lang parate, no? Yung diastereomer, yung iba na, no? Yung ibang hindi na niya kapareha, no? When it comes to the mirror reflection. Okay? So, yan. So, yan lang. So, ito. Sabi dito, can think as a family where there are 4 pairs of twins for a total of 8 kids. Each kid has 7 siblings where one of them is their twin. And the other 6 are diastereomers. So, good yung analogy, no? So, imagine mo daw, ito yung mga twins, no? So, may 4 tayong twins. Itong twin na to, itong twin na to, itong twin na to, itong twin na to. Itong bata na to, may 7 siyang kapatid. Ito, 2, 4, 6, 7. Pero, isa lang doon yung twin niya, yung iba, diastereomer. Ibig sabihin, hindi niya twin. Hindi niya mirror image, no? Okay, so ganun lang yung idea na. So good itong analogy dito sa baba na. Okay? So how will you know pala kung gaano karaming stereoisomers ang pwede mo makuha from a molecule? Kunwari ito. So paano mo malalaman na ganyang karami yung stereoisomers niya na 8? So, 8 yung kanyang stereoisomers, no? This is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, no? So, paano mo daw malalaman kung ilang stereoisomer yung kaya mo gawin out of certain chirality centers, no? So, this is the formula that we use, 2 raised to n, where n is the number of the chirality centers, no? So, for this molecule, 3 yung ating chirality center. Ayan, ayan, at ayan, no? So, depending on how you arrange that, you can have up to 8 versions. So that's 2 raised to 3, that's 8. So that means you have 8 stereoisomers. So may 8 kang stereoisomer dyan. So ganun lang. For example, this one. What is the maximum number of possible cholesterol isomers? Sige. So let's try this. Ilang possible stereoisomers daw pwede natin magawa out of this cholesterol molecule. So let's check yung chirality centers. Is this a chirality center? Let's check. Yung katabing atom, CH2, CH2. Katabing atom, CH2. This is C. So yes, this is chirality center. So magkaiba ito sa nandito. Iba yung OH sa OH din, no? So, yan. So magkaiba tong part na to dito sa part na to. So, yes, chirality center yan. About this one, is this a chirality center? Tignan mo yung katabing atom. This is CH2, this is CH, this is C. So, yes, chirality center din yan. How about this one? Is that a chirality center? This is CH2, this is this is CH, this is CH, no? And that's H, no? So may tie tayo dito. Ito tie, ito, and this one. So punta ka sa next. This is C, this is CH2. So magkaiba itong side na to dito sa side na to. So yes, this is also chiral. Okay, how about this one? So this is H, this is CH, ito CH din, ito CH2. Pero mapapansin nyo, tignan nyo yung kadugtong na ito. Dito tayo, di ba? So, tignan nyo yung kadugtong niya. May C, then may CH2. Ito, ano kadugtong niya? CH2, then may CH. No? So, magkaiba itong group na to dito sa group na to. Hence, this is a stereocenter. So, this one then, no? Bilisan ko na, no? So, this is also a stereocenter. This one as well. This one as well. Yeah. So that one as well. And this one. So yan yung stereocenters natin for cholesterol. So how many stereocenters do we have? 1, 2, 3, 4, 5, 6, 7, 8. So how many possible stereoisomers yung pwede natin magawa dyan? So that's 2 raised to 8, which is 256. Dami, no? Ang dami palang isomers ng cholesterol na. Okay, so ganun lang yung idea, no? So yun, the maximum number of stereoisomers you can have is 2 raised to n, no? So n is the number of stereocenters that you have in your molecule. So yun lang yung mga kailangan keep in mind nyo. So ano yung kailangan i-keep in mind? Yung diastereomers. So ano yung diastereomers? Sila ay stereoisomer, yes, pero non-superimposable and not mirror images compared to enantiomer. Itong enantiomer, may isang kapartner yan. Yung twin niya, yung kambal. Ito naman yung iba niyang kapatid na hindi niya kambal. So, ganun na lang yung logic dyan, ha? So, how will you check that? And i-check nyo kung mirror image yung dalawang molecule. So, if they are not mirror image, then diastereomer yan. Okay? So, ganun lang. Okay. So, let's proceed to the malapit na tayo matapos, no? Okay. So, ito, mga skip na lang to, no? Mga idea na lang. Okay, so let's proceed with the symmetry. So, from the word itself, symmetry, ibig sabihin nun, may parang reflection, no? So, parang may kung ano itsura ng kaliwa, yun din yung itsura ng kanan. Okay, so let's read this. Sabi dito, any compound with only one chirality center will be a chiral compound, no? As usual. Okay, so as usual, ganun talaga mangyari. However, if you have more than one chirality center, then a compound may not be chiral because of the plane of symmetry. So, ano yung ibig sabihin nun? Same lang kasing itsura niya kahit baliktarin mo. So, that means, ano yun, hindi yung chiral pag ganun daw. So, let's consider this two stereoisomers here. So, this is the trans, nasa taas yung isa, nasa baba yung isa. This is the cis, no? So, napapansin nyo, ang cis ay may plane of symmetry, no? So, if you will place this, nabulo na ako. If you will place a line in between this bond, no? Teka lang. So, kunwari, naglagay ka ng glass dyan, mapapansin nyo, kung ano itsura dito sa kabila, yun din yung itsura sa other side, no? So, whenever we have plane of symmetry, we call them the meso compound, no? So, sir, saan ba yan usually nakikita? Usually nakikita yan kapag you have cyclic compounds, no? So, if you have cyclic compounds, then you can have plane of symmetry, no? Okay. So, yan. So, tatlo na yung meron tayong stereoisomer. We have enantiomer, mirror image, non-superimposable, diastereomer, that is non-mirror images, non-superimposable. Yung ikatlo ay meso compound. So, meso compound exists when you have a plane of symmetry in your molecule. So, that means kapag nilagyan mo ng hati sa gitna yung molecule mo, kung ano yung itsura ng kabila, yun din yung itsura ng kanan. So, they are identical, no? So, identical sila. So, for that reason, no, there will be less number of stereoisomers for meso compound. No? Mababawasan yung dami ng stereoisomer mo pag may meso compound ka because of the identical image. No? So, yun. Kaparehas lang kasi. So, ayun. No? So, yun. Mababawasan yung iyong dami ng stereocenters. So, yun lang. So, yan na. Meso compounds, you have a plane of symmetry that usually exists for ring compounds, no? Such as this one. So, parehas yan nasa taas. Pag yan, binaba mo, same lang din yun as sa nakapataas. No? So, ganun yung idea dyan. So, if a compound is a plane of symmetry, it is achiral. So, yan. So, ito yung reason why yung ating meso compounds, no? So, hindi sila chiral at all. So, same lang sila, no? So, parang flinip mo lang kasi yung molecule. So, they are not chiral at all, no? Okay? So, overall, a compound that has a plane of symmetry is a chiral. So, hindi talaga siya stereoisomer, no? Ano siya? Same molecule lang na binaliktad mo lang, no? Parang pancake pag binaliktad mo. Parang ganun yung molecule, no? So, binaliktad mo lang siya. Pag binaliktad mo ulit, ganun pa rin naman yung itsura niya, no? So, yun. So, medyo mapanlin lang to, no? So, when we have plane of symmetry in our molecule, you cut the molecule in half, no? Makikita mo na, uy, same to sa left at sa right side. So, that is meso compound, no? Okay, so yan. So, if you do not have plane of symmetry, edi chiral yon usually, no? So, these are the example of meso compounds. For example, ito. Ayan, so hatiin ko to sa gitna. Mapansin nyo, itong left at yung right ay parehas lang. Okay, so they are the same, no? Baka kasi mamaya, ang i-drawing nyo ay ganito, no? Ay, hindi, tama lang pala. Okay, so yan. So, whenever we have a plane of symmetry, for example, hatiin mo yan sa gitna. So, that means this is a chiral, no? So, meso compound lang yan. So, mapanlin lang yan. Okay, so how about this one? So, if you cut it here, there is a plane of symmetry. So, this is a chiral as well. So, as well as this one. So, mapapansin nyo, ito hindi siya ring. Pero tignan nyo, no? Kung ano itsura ng left side, yun din yung itsura ng right side. So, that is a meso compound, no? So, that is also a chiral. Okay, so yun lang. And then when we have meso compounds, we have less than the predicted number of stereoisomers based on the 2N formula, no? So, yun lang. Ano lang yung kailangan nyo i-take note. Take note that meso compounds are achiral because of the symmetry. So, yun. Achiral to. Achiral din to. Achiral din yun because of symmetry. So, yun lang. So, tatlo na yung meron tayo, ha. We have enantiomer, diastereomer, and meso. So, enantiomer, mirror, non-superimposable. And diastereomer, non-mirror, non-superimposable then. When we have meso, we have plane of symmetry. So, pag pinutol mo yung molecule, kunwari, naglagay ka ng boundary dyan, mapapansin mo, uy, same lang to dun sa kabila, no? So, that is a meso compound, no? So, that is a chiral, no? Okay? So, ganun lang. Okay, so let's proceed with the other configurations. So, we have next is the Fisher projection. So, na yung Fisher projection, so ganito lang itsura niya. Ayan, vertical lines instead of zigzags. So, itong vertical lines, pinapakita dyan yung bonds na nakadugtong sa kanya. So, itong horizontal lines, if you're going to make it 3D, yung horizontal lines that is usually pointed to you, such as shown here, nakapoint sa iyo, then yung vertical lines that is pointed away from you. So, yung nakapatalikod. Okay? So, saan ginagamit yung Fisher projection? We use that in representing sugars. No? Sugars. So, for example, ito. This is one sugar. This is another sugar. Ito, sugar din to. So, how can we know yung mga chirality center dito? So, easy lang. For example, ito. Mas madali nga dito pag naka-Fisher siya. Para ito, titignan mo tong carbon na to. Ano yung nakadugtong dyan? Ito, at the rest ng ito. So that means this is a chiral carbon. Kasi may 4 different groups, diba? Ito, tignan mo. Is this chiral as well? Tignan natin. We have CH2OH, we have H, we have OH, and then the rest of the molecule. So this is also chiral. So mapapansin nyo, yung intersection, no, carbon, they are usually chiral when we have Fisher projection. So this is chiral, so we have 2 chirality centers here. This one, and this one, they are also chiral. This one, they are also chiral. No? So yun yung good thing with Fisher projection. Most of the time, yung intersection ng 4 na lines, yung carbon na yun, that is chiral. No? So yeah, we can also check the stereoisomers, stereo relationships of our substances with with the Fisher projection. So it's like placing a mirror as well, no? May mirror ka dyan. No? So mapapansin nyo, this is a mirror image of this one. So para sila ng position na. So ito, ayun, naka-mirror sila. So these are enantiomers. However, kung ito, makikita nyo, hindi sila mirror image kasi itong BR na to, instead of nandito siya, nandun siya sa likod na. So that means they are not mirror image and they are not also superimposable. So they are indeed diastereomers. No? Okay. So mas madaling mag-visualize with Fisher projection, di ba? Oo, madali. No? So ganun. So mas easy to. Although this is used in sugars, no? Usually in biochemistry. Pero yun lang. So that's Fisher projection. So one way to check if that is enantiomer or diastereomer is gawa ka lang ng mirror. So kailangan, ayun, nag-mirror sila, pero pag patungin mo yan, they will not superimpose. No? Kasi ito, pag pinatong mo to dito, yung BR nandito sa left side, no? Ito nasa right side. So non-superimposable yan. How about this one? Ito, hindi na nga sila mirror. Pag pinagpatong mo pa, hindi rin sila superimposable. So that means diastereomer yan. No? Ito yung mga conversion. Ito yung na-discuss natin last time, mga gauche conformation, mga anti-conformation. So, yan. So, alam niyo na naman yan eh. Yung mga gauche conformation, anti-conformation. Okay? So, ganun lang. Ano pa ba yung mga kwento dito? Chirality without chirality centers. This is more on complicated stuff na. No? So, I will not cover this. This usually involves inorganic, organic molecules. No? Diba? Mahirap isipin, no? So anyway, so skip na natin yung part na yun. So hindi naman natin kailangan yan sa ngayon, no? But anyway, so let's proceed with the last part of our topic, no? Which is the resolution of isomers, no? So sabi nga natin last time, no? Yung ating isomers, they have different properties, diba? So that means, since they have different properties, you can separate them, no? So one way is by distillation, the other is by recrystallization. So because one enantiomer is different than the other, no? So, yan. This applies for This applies for other isomers, no? Stereoisomers. Pero when they are enantiomers, no, they will not be used. Bakit? Kasi yun nga, they have similar identities. No? Yung reactivity lang pala yung magkaiba sa kanila pag enantiomers sila. I forgot. No? So anyway, so yun lang yung idea. So we can resolute our enantiomers. Pwede natin sila i-identify, pag-iwalayan by these processes. Pero kapag enantiomer yan, medyo mahirap because their chemical properties are, the physical properties are similar. Ano yung pinakaiba lang? Chemical properties, no? So, for example, we have this one. Ito, Fisher projection. So, as you can see, this is a mirror image of this one. So, enantiomers to, no? So, anong ginawa dito? Louis Pasteur performed the first resolution of enantiomer from racemic mixture. When we say racemic mixture, you have enantiomers, no? So, mixture siya ng enantiomer. So, this is one enantiomer, this is the other enantiomer of the tartaric salt. The different enantiomers form different shaped crystals that were separated by using hand tweezers. Ang effort. So, kinamay-kamay niya pala yan. Kaiba daw yung itsura nila. So, anyway, at least alam natin idea na pwede, no? So, another method of using, of resolving enantiomers, no, para mapag-iwalay sila is to use the chiral resolving agents, no. Kasi yung ito kasi, ang good thing lang dito sa ginawa ni Louis Pasteur is that they form different crystals. However, if the molecule is not forming it's if the molecule is not forming crystals, then mahirap, no? So we use chemical means or chemical reactions instead, no? Kasi there are chemical reactions that are stereospecific, no? So kung ano yung maging product ng isa, different siya sa kabila, no? So yan. So we use chiral resolving agent. Then the other one is affinity chromatography. So ano meron sa affinity chromatography? Depending on the shape, no, or the chirality of your molecule, doon depende yung pagkabit niya sa kakabitan niya. So imagine that as the lock and key, no. So yung mga susi iba-iba yung itsura. Yung lock specific siya for one isomer, no. So yun yung idea with affinity chromatography or the chiral adsorbent, no. Okay, so last part, no. Matapos na rin tayo. So for the last part, we have the E and Z designation for alkenes, no. So if we have alkenes, I think last time na sinasabi ko, E and Z. So paano natin i-designate yun, no? So for molecules with different groups attached to the C double bond C, we can use the EZ notation instead of cis and trans, no? Kasi when we have cis and trans, kailangan same yung dalawang groups. However, for this type of molecule, hindi mag-a-apply yan. Kasi tignan nyo. Kasi kung mapapansin nyo, that is not adequate to differentiate these two types of diastereomers, no? So, bakit, no? Kasi ibang usapan pag double bond. Ano yung point of view natin pag double bond? Kung sino yung nasa left side, kung sino yung nasa taas, sino yung nasa baba ng double bond, no? So, to use the E and Z designation for alkenes, ganito lang yan, no? So, tingin ka lang sa left side and the right side of your double bond, no? Then you prioritize them based on atomic number. Parang Cahn-Ingold lang din, no? For example, ito. For fluorine here, ito, this gets priority over this carbon. Etong N, this gets priority over the hydrogen. Okay, so ganun. So this is the priority here. This is the priority here, no? Then, after mo malaman yung priority, if the priorities are on the same side of the double bond, for example, in this case, if they are on the same side of the double bond, then that is the Z isomer, or the Zusammen. Okay, the Zusammen, ito ay German word, no, for together, togetherness, no. So Zusammenhalt, no. So yan, together yan, pag ganyan. So ibig sabihin magkasama yung priority, nasaan na lahat. Tapos kapag yung priority nasa opposite side ng double bond, for example, this is the double bond, ito yung isang priority, tapos yung kabilang priority nasa taas. So E yung ginagamit doon, entgegen. So entgegen, which means opposite, no. So yung nagturo sa amin sa review center, ganito lang ginawa niya. So check mo daw yung priority. Ito yung sabi niya sa amin. You check the priority, no? If sila ay magkasama sa double bond, ibig sabihin nun, they are Z. Magkasama. So, Z daw, kapag magkasama sila sa side ng double bond, such as this one, no? Magkasama sila sa side ng double bond na to. Pero kapag, pag magkahiwalay sila, ewalay. So, ibig sabihin nun, E isomer yun. Magkasama at magkaewalay, no? Zusammen and entgegen, no? So, yun. So, zusammen, magkasama ang priority sa side ng double bond. Pag magkaewalay, that's entgegen, no? They are on the opposite side of the double bond, no? So, for the last activity, let me finish this, no? So, sagutin ko tong lahat, no? So, for example, this is the double bond. So, ang aking basis ay ayan, no? So, pakita ko yung hydrogen na hindi pinapakita, no? So, anong gagawin ko dyan? Ito yung basis ko, no? Kung magkasama or magkaewalay, no? Pero tignan ko muna yung left and right side ng aking double bond, no? On the left side, which will be my priority here. Tignan natin. This is carbon. Ano yung nakadugtong sa carbon? Carbon uli. Carbon. Tapos, carbon, carbon, hydrogen yung nakadugtong yan. So, may carbon dito na nakadugtong, may carbon uli dito na nakadugtong, then dito may hydrogen dyan, di ba? May isang hydrogen dyan. So, ang mga nakadugtong dito ay carbon, carbon, hydrogen. About this carbon here. Ano yung mga nakadugtong dyan? Isang carbon dito, yung carbon doon, tapos dalawang hydrogen. Di ba may dalawang hydrogen dyan? Hindi lang pinapakita. Okay? So, yan. So, which will get the highest priority? E di syempre itong nasa taas, no? Bakit ito nasa taas? Kasi yung carbon na to, may nakadugdog sa kanyang dalawang carbon at isang hydrogen. Itong carbon naman na ito, may nakadugdog sa kanyang isang carbon lang, tapos dalawang hydrogen. So, lesser priority yon pag ganun. Okay, so, this is our priority for the left side. On the right side, sino yung priority natin? Siyempre, hindi yung H. Obvious yan. Hindi yan. No? Ito yung magiging priority natin. So, are the priorities on the same side of the bond or not? So, mapapansin nyo, ito yung priority 1, nasa taas. Ito yung priority 2, nasa baba ng double bond. So, they are magkaewalay na. So, this is E. No? So, siya ay E isomer. No? So, magkaewalay. Okay? So, E yan. So, nasa taas at nasa baba, ewalay. And gigen. So, let's try this. B. So, again, check on the left side and the right side now. So, on the left side and on the right side, sino yung priority? Obviously, ito yung magiging priority. Bakit? Ano yung mga nakadugtong dito? Ang nakadugtong sa carbon na to ay carbon, carbon, and hydrogen. Ito, ano ba yung nakadugtong dito? That is carbon. I mean, hindi pala carbon. Hydrogen lang yan lahat, no? Methyl group yan eh. So, hindi natin priority to kaysa dito. So, ito yung mas priority. So, how about this part? The right side of the molecule. So, check natin itong carbon na to and yung carbon na to. So, for this carbon, ano yung mga nakadugtong dyan? May tatlong carbon na. Carbon, carbon, carbon. For this carbon naman, ano yung mga nakadugtong dyan? This carbon, carbon, and one hydrogen na hindi pinapakita, no? So, sino mas priority? Siyempre, itong tatlong carbon na nakadugtong sa carbon. So, ito yung mas priority. So, are they magkasama or magkaiwalay? So, this is Z, magkasama, zusammen. Okay, so, itong priority na to at itong priority na to, they are on the same side of the double bond. No? So, they are Z, magkasama. Okay? So, let's have the third one. Ito yung double bond. So, yun yung ating priority. No? So, check tayo dito sa left side. We have F and carbon. So, automatic yung F yung priority natin. On the right side, we have carbon here, carbon there. Tignan nyo yung kasunod na carbon. Oxygen dito. Dito, carbon pa rin. No? So, this will have the higher priority over the third butyl here. No? Okay, so, mas prioritize to kaysa dito. So, they are magkasama. They are on the same side of the double bond. So, that's a Z isomer. And last one. Ito yung double bond. So, yun yung basis natin. Pakita natin yung hydrogen na hindi pinapakita. Okay, so sa side na to, automatic, ito yung priority. Not the hydrogens, of course. Dito sa side na to, ano yung priority? Is it the carbon or the Cl? Hindi yung Cl. So, are they magkasama or magkaewalay? They are magkasama as well. No? So, Z isomer siya. Okay, so that's how we designate the stereoisomerism of compounds. No? So we have the E and Z for double bonds, no? For butenes. No? So yun. So yun lang. And for the next meeting, kasi by Wednesday, I will be going to my to my alma mater, no? So I don't know if maaga ako makaka-uwi considering the situation of the traffic, no? Pero anyway, so I might be recording another class lesson para may mapanood naman kayo on Wednesday, na. So yan. So that's all for this chapter. So let's have a quick summary. Quick summary lang ng stereoisomerism. So in stereoisomerism, uh, meron tayong isomers, di ba? Punta tayo dito. So, meron tayong constitutional isomerism, iba-iba yung connection. Stereoisomerism, iisang atom na dinugtugtungan, pero iba yung orientation in space. No? So, for stereoisomers, we can have enantiomers. We can have, diastereomers. And we can have meso, and as well as E or Z for alkene. Okay? So, ano yung pinagkakaiba ng apat na yan? So, enantiomer, yan ay mga mirror image, pero non-superimposable. Pag diastereomer, non-mirror image, and non-superimposable. Pag meso naman, ito achiral yan, because of the plane of symmetry. Itong E and Z, yan ay magkasama or magkaiwalay yung priorities sa left side and sa right side ng double bonds. No? So, yun. So, yun lang. Then, ano pa yung kailangan natin na malaman dito? Especially, ang pinaka-importante na malaman nyo is yung RNS configuration. Na? So, yan. So, the Cahn-Ingold-Prelog system. So, paano lang yan? So, rule number 1, prioritize the atoms based on the atomic number. Then, you arrange the molecule in such way the least priority is facing away from you. Then, you rotate your molecule. Pag clockwise yan, that's R. Pag counterclockwise, that's S. Okay, so ganun lang. O, yun lang naman yung mga kwento natin. Ano meron sa optical activity? Yung ating molecule, yung kanilang stereoisomerism, they can result to the bending of light. Optical activity yun. Okay, so we can have a positive rotation, which is dextro-rotary, and the negative rotation, which is the levo-rotary. Okay, so yun lang. So by the way, there's no correlation between RNS and dextro-rotary and levo-rotary. So hindi sila fixed na pag R positive, pag S negative. Hindi ganun. So there's no correlation. Depende na yun sa property ng molecule. Ayan. Ano pa? Ito, the maximum number of stereoisomers is 2 raised to n. Okay, so just count the stereoisomers, then 2 raised to n lang yan. For example, for our cholesterol molecule, we can have up to 256 isomers, stereoisomers. And then the symmetry, when we have plane of symmetry, we have meso compounds. So meso compounds are generally considered as achiral. So achiral siya. So paano mo malalaman kapag meso compound? Kunwari, ganyan yung itsura. Hatiin mo sa gitna. Pag same yung itsura ng kaliwa at kanan, taas at baba, they are meso compounds. So they are achiral. In Fisher projection, ito yung easier way to see the chirality centers. So yan. So we use this for sugars. We can also see clearly the enantiomers here and the diastereomers. So enantiomers in the Fisher isomer, yun parang mirror image sila. Though pag pinagpatong mo yan, hindi sila magpapatong talaga. Yung BR hindi papatong dito. Dito yung papatong sa kabila. So non-superimposable. Okay, so pag diastereomer, again, hindi na nga sila mirror image, hindi mo na sila pwede pagpatungan. Okay? So yun lang yung idea ng diastereomers. A resolution of isomers, how can we separate isomers? Enantiomers. We can use distillation, recrystallization, or mga chiral resolving agents and affinity chromatography. And the E and Z designation, so alam nyo na yan, depending on the priority number, kapag magkasama sila sa side ng double bond, they are magkasama, Z. Pag magkahiwalay sila sa double bond, that's magkaiwalay, E and Gegen. Zusammen and Gegen. Okay, so that's all for this chapter 5 now. Stereoisomerism. So the next chapter would be chapter 6, which is on chemical reactivity. Yun, mas mabilis yan, no? So anyway, so that's everything for today, no? So hopefully ma-visualize yun na maigi, no? So yun lang yung wish ko talaga kasi ang hirap i-visualize lalo na sa online class, no? Unlike kapag in person, mas madali ituro yung hand rotation. Pero practicein nyo lang, no? Ulit-ulitin nyo lang yung video na to see, no, kung paano yung nangyayari. So yun lang. So if you have any other questions, just let me know, no? And so I'll see you again, no? And bye-bye. No? So next meeting we will have chapter 5, no? I mean chapter 6, no? Chemical reactivity na. Mabilis lang yan. So bye-bye.